Alright, hello everyone. My name is Quent Hartt. I'm a fourth year at Chem E here at OSU. I'm graduating next year at the spring of 2021. And this video was made possible through the Student Active Learning Initiative, sponsored by our very own William G. Lowry, Department of Chemical and Biomolecular Engineering. And in this video, I'm going to be giving a brief introduction to the material balance equation, as well as the concept of a material balance. Alright, so overall, I'm going to describe what a mass balance is, as well as the general equation we're going to be using for solving actual problems, and then walk more into how it's going to be useful within this course in 2200, how it's going to be useful at your career as an OSU student, as well as the rest of your curriculum and chemical engineering, and then potentially how it could be used in your career as well in the real world once you get a real job. So after we go through all that, I'm going to be just introducing a very quick example problem for you to think about to try and walk through everything that was introduced in the video. So, what is a balance? The way I think about it when I was first introduced to it is that it's very similar to a real balance, or what a real balance is, which I have on the right. And the concept of a balance is very much just trying to make two sides equal, or trying to equate two different things. And similar to the word, we're going to be balancing what comes in and out of a system for chemical engineering. And so what this means is we want to know where everything came from, how much of it came in, knowing where everything went, and how much of it went out. And so knowing all this, we want to balance that to make sure they're equal. A quick aside, for systems, you're going to go over this in much more detail in class and how they can be used to actually solve problems, but I wanted to introduce it very quickly as a concept. So, the system is going to be the black box around the stuff that you care about, but you don't have to know what's going on. And you've already done this before, so I'm going to go over a real quick example to try and help solidify this. So, in general chemistry, let's say we have a reaction that has molecule A. It reacts with itself for some light to go to A prime, and then with molecule B, it can go and react to form AB. But then, let's say there's two of these molecules that react together to form C. So what we've effectively drawn is a pseudo mechanism for this process, or how this would actually go on. But you are never going to need to know this as a chemical engineer. You're going to need to know more of the overall process. A chemist, maybe if you're designing a reactor, you want to know this stuff, but as a general rule for this course, you don't need to know the details of chemical mechanisms. So what you can do is draw a big black box around this internal mechanism, and you're just left with what comes in and what comes out. And you've already done this before just by writing this equation. So in this equation, effectively the arrow is your black box, and we're going to be doing that very much so in the coming months in this class. Okay, so now that we know a little bit about what a balance is and what a system is, what is a material balance for chemical engineering? I think, and how it was best explained to me, is that a material balance is just a balance applied to chemical engineering so that we can actually solve equations and problems. And here we're just going to be balancing a different material. And this material can take a whole bunch of different forms. It can be mass, a specific chemical to make a component balance, which you'll learn about in class. It can be an energy balance, which will be used also in this class later. You can also do momentum balances to learn about the velocity profiles inside of pipes, or you can do a money balance. You can balance the amount of money entering or leaving your plant to see how much profit or stuff you're going to have. And this will actually be used in a later course as well. For this course, you're primarily just going to be doing mass, a specific chemical like a mole or an atom, as well as energy. So, to kind of help solidify this, baking a cake is a form of a balance. You need to know how much goes into your recipe, and you know how much comes out. So, just going through, you're going to put 3 cups of flour, a tablespoon of baking powder, and half a teaspoon of salt into a bowl to mix all your dry ingredients together. Then in an actual mixing bowl, you're going to beat in your 2 sticks of butter, 1 1/4 cups of sugar, slowly beat in 4 eggs, add in a tablespoon of vanilla, and then slowly add in your dry mixture with your milk. Put this thing in the oven at 350 for 30 to 35 minutes, and out comes your cake. But overall, we can look at your kitchen as your system, for an example, and put a black box around it, and we again have our n equals out. And you've already done this before using these material balances in your life. Maybe you just hadn't thought of them that way. So an easy way to actually solve problems like this is if you've ever made a double recipe for your, like say for this cake. Is if you want to make 2 cakes, it's a real simple process of just doubling all of the ingredients. And so that's just a very simple example of some of the types of problems or how you can actually use this to solve problems in chemical engineering. So another quick thing we're going to go over is kind of imagining balancing your checking account. We're going to imagine your bank account is going to be our system, and we're going to look at what comes in and what comes out. So if you just think about how the different ways that money can move around in your checking account, you can deposit money, you can withdraw money, you can earn interest on the money inside of your account, or the bank can take out some of the bank fees. And so it'd be super useful to have a mathematical equation to know how much money you have. So here's where the general balance equation can come into play. This is just a mathematical expression for the material balance. We're accounting for all of the material at all points in time, coming into our system, coming out of our system, and some of what's changing in our system. So we can put stuff in, we can take stuff out, we can have a generation of what we care about inside of our system. What we care about can be consumed inside of our system, and it'll be useful to think about that for reactions when we get to chemical engineering. But we can also have accumulation. So if we're putting in more than we're taking out, we're going to be accumulating stuff inside of our system. And all this will be in much more detail in your actual class, but just introducing this in the form of a checking account I thought would be helpful, just as a general glance. So how does this actually relate to the example I just presented? So deposits would be a form of putting money into our bank account. Withdrawals would be taking it out. Interest would be a form of generation of money, if you want to call it that. And then bank fees could be a sort of consumption of our money is being consumed inside of our bank account. So then that leaves accumulation. What does it mean in this system? All right, so accumulation in the system is going to be accumulating money. So it's just going to be the amount of money in your bank account that's being increased. And specifically, I think of it as savings. So we can write, using the general balance equation, this overall equation for the amount of money in your bank account. And so with this equation, we can actually now solve problems. You can do this process on almost anything you want that has stuff flowing in, out, or being changed inside. And you can solve equations. You've already learned about, I believe, mass fractions, mole fractions, and stuff like that. That will be used in conjunction with this equation to help solve for unknown variables. And actually, based on your system, whatever you have defined, whatever is known and given to you, you can determine a certain amount of unknowns. And actually, there's an analysis called the degrees of freedom analysis, which will help you determine how much you can solve for. Because it might be that your system is underdefined and you really can't solve for everything. But if you assume something or take a basis, which you'll learn about in the future, can help you be able to do what you need to do. On the other end, it could be that you know too much, or too much is defined, or it's overdefined, and a degrees of freedom analysis will tell you this system doesn't work out. We know too much and it doesn't work. Okay, so that was just a general concept of the general balance equation and what a concept of material balance is. How is it useful to you? So in 2200, nearly everything is going to be based around this equation from now on. You're going to be writing mass balance for like a mass, a mole, or atomic balances to solve for how stuff is moving within a process diagram. You can solve for the flow rates or the individual component flow rates or mass fraction, mole fractions within your streams. But you can also do a balance on energy. And so this can help you solve the amount of energy you have to put in the system, the amount of energy you can take out in the form of work, or the amount of heat you have to put in. It's just different ways that you can solve for stuff to figure out everything about your system, a way you can balance what goes in and what goes out. So how is this useful in the rest of your career here at OSU? Well, I'm not kidding when I say in literally every chemie course, you're going to be using this equation in some form or another. In separations, you need to know how much goes in, how much comes out of your separators. In transport 1, you get a little more unique, and you're going to write momentum balances to kind of understand how fluid's going to be flowing in your system. For transport 2, you're going to be writing energy balances to determine how heat flows and how energy is going to be transferred to change the temperature of different parts of your system. Then you can get to thermodynamics to again write some energy balances to determine, is this process where I separate this two chemicals, is this actually possible or not? You'll even get into entropy balances, which is way down the road, but using a balance is going to be a key part of what you do as a chemical engineer. And this actually goes into, how this is useful in your career. So a friend of mine is actually, they did a couple summers ago, they were a refining operations research intern at Marathon in Findlay, Ohio. And they worked at the refinery, and they said that actually the majority of their job was dealing with mass balances. So at the refinery, after different unit operations, they'd have flow meters to determine the volumetric flow rate coming into and out of different components in their refinery. And all of these different flow rates were actually ported to an Excel document where it was converted to mass. And then based on the amount of mass that left the system versus in the system, they wanted to make sure that was equal or that it balanced. And so how they actually did it was they took out over n divided by, or times 100, apologies. And then they wanted that to be between 102 and 98. So if this process was perfect, out over n would be 100 every time, because in your refinery, you don't want to build up of any of your materials, you don't want leaks, you want everything, all the mass that you're putting in, to be coming out. And it was her job as a research intern here, as well as she was telling me that a couple of her coworkers, it was their full-time job, to look at the different mass balances and make sure they close. And that means the out over n times 100 is within that range. And if it didn't close, or if it wasn't within optimal parameters, it was their job to go and figure out why that is. And that could be just they were doing some calculations wrong, or there could have been a bigger problem within one of their units. And so her entire job, and a lot of her coworkers' jobs, was mostly dealing with just mass balances on a daily basis. And I don't want to make promises, but with a very high probability, I will say that you will use a mass balance or some form of a material balance in your daily job as a chemical engineer once you get out into industry. Okay, with that, just some food for thought. Think about what the general material balance equation would look like for the amount of people inside of the state of Ohio. And so with that, you'd want to think about what's coming in, what's coming out, what's causing generation, consumption, and what is being accumulated. What would you call it? Okay, thank you for your time. I wish you all the best in lecture.